Hello, my name is Christian Farinella, and in this short video I'll take you through the process of creating a local Kubernetes cluster using Docker Desktop on a Windows 10 machine. For this video you will need to have installed WSL2. If you need some help to perform this step, check out our video on how to install WSL2, the link will be in the description. Before getting started, I'll provide a high-level definition of Docker and Kubernetes in case you are new to these technologies. So, what is Docker? Docker is a technology that allows you to create and tag OCI-compliant images and upload those images to remote repositories. Docker is also a standalone container engine and allows you to run containers from images, whether local or remote. Whilst Docker is synonymous with container and image creation, there are other tools that can create and run OCI-compliant images such as Podman or Builder. Next, what is Kubernetes? Kubernetes is a platform concerned with the deployment, scaling and management of containerized applications. A Kubernetes cluster consists of a control plane that runs several services to manage it. The main component is the API server that all calls are channeled through, including those from external CLI tools such as kubectl. A scheduler that works out which nodes will host a pod of containers, an etcd database that stores the state of the cluster, and a controller that monitors and maintains the desired state of the cluster. Alongside the control plane are one or more worker nodes that run two main containers, kubelet and kubeproxy. The kubelet receives information for container configuration, whilst kubeproxy creates and maintains the local firewall rules and networking information. When a deployment request is made to the API server, the controller and scheduler will work out which worker nodes will be used to create the pods. The API server will then communicate with the kubelets on the respective worker nodes and send a message to the local container engine to create the required containers. After pods have been created, all the kubeproxies are updated to facilitate service discovery. When using Kubernetes within Docker Desktop, the master and worker nodes run as a single node cluster without the need for any complex setup. This was a very simplified explanation. There is a lot more below the surface, but for now, let's get back to the install. To install Docker Desktop, head over to the website docs.docker.com. Click on the download and install link and select Docker Desktop for Windows. Here you'll see the system requirements and the download link for the install package. If you go ahead and click the download link, that will start the download of the executable. Depending on your internet speed, this may take a couple of minutes. Upon completion, run the Docker Desktop installer. Okay, once you're presented with the configuration window, make sure to leave the Use WSL2 option selected. Click OK. After you see the installation succeeded window, click Close and you'll be finished with the installation process. Okay, now that we've installed Docker Desktop, let's proceed to open the application. You can just type Docker in the search bar, click the app. Okay, after opening for the first time, you'll be presented with the service agreements. Notice that under the licensing terms, it's only now free for personal use in organizations less than 250 people. So if you fall into one of those categories, check the I accept the terms and click accept. Let's wait a short moment. Just have to wait for the Docker Desktop service to start on your local machine. Okay, so You'll be presented with this little tutorial, which we can skip for now, as there's a slightly faster way to test that everything's working okay. So you'll be presented with a Docker command on the home page to run the documentation website. So if you just copy this command and open a command prompt, just paste that in. So this command essentially will download the getting started image, run it in detached mode, which is the -D switch, and assign the running container to port 80 on your local machine. So as you can see from the trace, we didn't have that image locally, so that pulled that from Docker, remote Docker, pulled the images, checked the hashes, and then that should be started for us on localhost. So if you proceed to open a browser, type localhost, you've now got the documentation website running from that container that was created in the docker run command. So if we go back to our shell, we can run a few commands just to sort of see what's happened. So if we type docker image ls, you'll see the Docker getting started image that was downloaded. And if you type docker container ls, you can see the container that's actually running, and you can see that the port 80 has been mapped to that container. If we want to stop or start these containers, you can use docker stop and just grab the container name. You can go back to your browser just to check that stop, just refresh F5. You'll see site can't be reached, so we can go back into docker start to restart that container. And you can see that's back again. If you want to remove a container, you can type docker container rm for remove. So you'll more than likely get a message to say we can't remove a running container. So in this case, if we want to forcibly remove the container and stop it as part of the process, just add the -F switch. And then if we run docker container list again, we should see that list is empty. Okay, so now that we've established our Docker desktop is working, let's move on to configuring Kubernetes. So if we go back to our Docker app, go to your own containers, you'll see the little cog at the top for settings. If you select that, tip of the week, close. So on the navigation bar on the left, you'll see there's a Kubernetes option. So all we need to do here is click check enable Kubernetes, and then essentially click apply and restart. So very simple process when adding Kubernetes to Docker Desktop. So you just have to wait a few minutes for the containers for Kubernetes to be downloaded and installed, and then you'll have your cluster ready to go. Once installation is complete, you can test connectivity to the Kubernetes cluster using the kubectl tool. kubectl communicates with the API server on the control plane and is the primary tool to control your Kubernetes cluster. To view services, proceed to open a command prompt and type the command kubectl get services. Here you can see the Kubernetes service that's running in the default namespace. If you want to see all services across all namespaces, simply add the switch all namespaces. And you'll see there's also a kubedns service running in the kube system namespace. Next, we can view the pods running on the in the cluster with the command kubectl get pods. So again, we'll see there's nothing in the default namespaces. We've not deployed anything yet. But again, if we add the switch all namespaces, you'll see that all the Kubernetes containers running as part of the control plane are listed. So we've got the API server, the controller, the scheduler, the etcd database, and also some DNS and networking services required to run the core Kubernetes. Now we'll proceed to create a deployment using the kubectl create deployment command. So simply type kubectl create deployment. We just give it a name, in this case demo Nginx. Provide the name of an image, Nginx, and we'll also specify a number of replicas, which we'll specify as 3. Okay, so you can see the deployment's been created. So if we use the command ctl get deployments, you'll see here that it's created 2 of the 3 pods. So again, we can run this command again, and we should hopefully see 3 of 3. Excellent, so the deployment is complete. If we want to get some pod information, use the command ctl get pods again. And we can see Kubernetes has created 3 Nginx pods for us, which are all running. To get some additional information such as pod or the container IPs, we can just add the wide switch. And we'll see here we've got the IP addresses that have been allocated to each of those pods. If we want to access these pods, as pods are volatile and can be destroyed and recreated at any time, we need something more permanent to connect to from outside the cluster. So we can expose a deployment, which will essentially create a service that will route traffic to the pod containers. So we do this with the kubectl expose deployment command. Just need to pass the name of the deployment and a port that we want to forward to. Okay, so we can see that's exposed. So now if we type kubectl get services, we have a demo Nginx service listed with the cluster IP and the port allocation. So this cluster IP is again only accessible within the Kubernetes cluster. So to access this from our host machine, we need to set up a port forward. So we can do this with the kubectl port forward command. So we just need to type kubectl port forward and the name of the service and the port assignment for our local to the cluster. Okay, so now if we go to a browser and go to localhost on port 17,000, we can see the Nginx default page listed. So just to recap, we've created a deployment, we've exposed that deployment with a service, we've set up a port forward, and then we've successfully been able to access that web server. The only problem with the port forward is that I guess once this window closes, the port forward will cease to exist, so it's not a very permanent solution. So what we will do in a future video is cover the use of an ingress controller, which gives you a more stable solution for accessing your services from outside the cluster. This concludes the video on how to set up Docker Desktop on a Windows 10 machine. If you have any questions, please leave them in the comments below. Also, please like and subscribe if you enjoyed the content, and we'll see you again soon. Thanks very much.